So, good morning to all. Today we have to see the evaluation metrics for classification. Okay. So, in machine learning, evaluation metrics for classification are the essential to measure the model's performance. It is used for the model performance. This matrix depends on the types of classifications problem. Okay. So, this evaluation we did on the classification problems. Okay, so these evaluation metrics are crucial for measuring the performance of a classification model. This matrix depends on the type of classification problem and and are often based on the confusion matrix, which summarize the model's prediction against the actual labels. Labels data means anyone what is mean by label data? True or false? Okay, like that. The confusion matrix means there is a true positive, true negative is there, false positive is there, false negative is there. Okay, so true positive means correctly predicted positive instance, and the true negative means correctly predicted. So let's see the what is confusion matrix in machine learning. A confusion matrix is a table that summarizes the classification model's performance by predicted, comparing the predicted and the actual labels. Okay, it is specially used for the evaluating the binary and the multi-class classification models. We use this specially for the binary and the multi-class classification models. So these metrics are based on the confusion matrix, which consists of the true positive, true negative, false positive, and false negative. So true positive means correctly predicted with positive instance, and true negative means correctly predicted with negative instance. False positive is incorrectly predicted but positive instant. And false negative means it is incorrectly predicted with negative instance. Okay, this is known as confusion matrix. So first of all, we have to see the accuracy. So accuracy is a key matrix used to evaluate the performance of the classification model. Accuracy is a key matrix used to evaluate the performance of the classification model. It measures the proportion of correct prediction output of the total prediction. So anyone have idea on the formula of the accuracy? So what is the formula of this? Correct prediction upon total prediction. Okay. So one more formula, like there is a true positive and true negative. Like the formula of the accuracy is true positive plus true negative divide by true positive plus true negative plus false positive plus false negative. Okay, both this all. Okay, so it takes all of this. So it takes this all. Okay, means in the like what is the accuracy that it has a definition is true positive plus true negative. It gives the addition of this both. Okay, it gives the addition of both and the division of all four confusion matrix. Okay, so TP plus TN divided by true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. So this is the formula of the accuracy. So measures all overall correctness. It measures the all overall correctness. The data can be misleading if the data set is imbalanced. If the accuracy will be mislead if there is a database is imbalanced. Imbalanced data means there is a duplicates value are there, some blank rows are there, some blank data is there, some missing values are there. Okay, so this is known as imbalance data set. So work well when the data set is balanced. Accuracy is work when the data set is balanced. Let's see one example for the true label and predicted label. So, so what we have to do is, so first we write import time we write. So here what we have to do is, why it is not coming, import time we write. Then here we write from sklearn sklearn dot matrix we write import accuracy score. We have to import accuracy score from the sklearn matrix. Then here we write some true values like true labels and predicted labels. Okay, so we write here y as true. So this is true labels, and here we write 1 0 1 1 comma 0 comma 1. Then here we write 0 comma 0 and 1 comma 1. Like this we have to write 1 2 3 4 5 6 7 8. We take a 10 true label, and now we have to take the predicted labels. So here we write pred by underscore pred we write. Then here we write 1 comma 0 comma 1 comma 0 comma 1 0 comma 0 comma 0, then 1 comma 0, then here we write 1 1 1. Like this we take the data set of the true label and predicted label. So the y true is the actual value, and the prediction from the model prediction we got this prediction, this predicted label. Okay, so let's see. So here we write accuracy. Here we write accuracy is equals to, here we write accuracy score. In bracket we have to write y true comma y predict. Like this we have to write, and then we print this. Like we have to write the f string we have to take. The accuracy is, so here we write, why it is not coming. So here we write accuracy. So here we have to write accuracy, and then after this here we write comma dot two. Like this we write. So let's see what output it will give. So it takes a little bit time for the output. So it gives an accuracy of 0.80. So what is meant by 0.80? Anyone? 0.80 means 1 means how many percent? 80 means how many percent? 0.80. It means it is an 80% accuracy is corrected from predicted model. This is the labeled. Okay. This is the actual values which we are given, and this is the prediction by the model. Okay, so from these both, the accuracy we got is 80% of accuracy we got. Okay, like we our model is the doing the prediction is correctly. Okay, so this that means of this code. So any doubt in this code, guys? So we have to we how many prediction we did correct. So here we did the correct prediction is 8. Okay, like here 1 2 3 4 5 6 7 8. Yes, 10 prediction we write correct and 2 is incorrect prediction, and total prediction is 10. Okay, so here 2 prediction is wrong and 8 prediction is correct. So we use the accuracy score for perform the calculation for the accuracy, and we use the what we called in this, we already saw this one in Python. What we saw this, where we saw this, anyone? A formatted string. This is known as formatted string. Okay, so why we write dot 2f? Dot 2f means rounds the accuracy to two decimal places. Okay, so let's see the code for now. We have to see the code for this is for accuracy. Now we have to see the code for the precision. Okay, so what is the formula for precision? Precision, yes. Now we have to see the code for the precision. So precision measure how many predict positive are actually positive. It's important for avoiding the false positive, especially in case like spam detection where the false positive could be annoying and the disruptive. So formula of the precision is true positive upon true positive plus false positive. So let's take an example of this, like if a model predict five positive instance and four of them are actually positive, the precision is 80%. So let's take an example for this also. So let's see here, we take the example for the precision. How many predicted positive are actually positive? We have to check importance for avoiding false positive in case of like spam detection. So let's take a code for this. So here we write we have to find for the precision score. Okay, so we take the complete same data, just we have to do the precision. Okay, precision score we have to find. So we didn't take this one, we take the data or this one data only. Hello guys, I'm audible now. Hello.
Yes, sir.
Okay,
Yes, sir.
so here we write the true actual values and the model prediction. Y true is the actual value and this Y prediction is the model prediction. Okay. So here we have to import from sklearn dot matrix import precision score. Okay, so from sklearn dot matrix we import the precision score, and this one is actual data and this one the model predicted data. So let's see. So what we have to do is we have to calculate the precision. So here we write the precision equals to precision score. In that y score, y true we have to write comma, y predict we have to write, and then we have to print this. So for that we take f string, formatted string we take, the precision is, so here we write the precision is, and here we have to write precision, like this we have to write, and we give the, we want up to the 2 decimal. So here we write equals to is to 2f, like that we have to write. So let's check what it will give the output, how many precision is there, precision score. So it gives the precision score as a 83%. Okay, so our prediction and actual is precise. So it is a 83% of. So y true is represent the actual correct label in data set, and y prediction represent the label prediction predicted by the model. Okay, each element in the list correspond to the single. Okay, like 110010, it's on single. Okay, it is correspond to each other, like 0 is correspond to 1, this 1 is correspond to this 1, this 0 is correspond to this 0. Okay guys, so here true positive is 5 and false positive is 1. Okay, the function precise score automatically calculate this. Okay, so let's see the next topic is recall. It is also called as sensitive or true positive. Okay, so let's take recall, also known as a sensitive or a true positive rate, measure how many actual positive were correctly predicted. It's crucial for detecting important events such as disease screening, where a false negative could have serious consequence. Okay, so recall is also known as a sensitive or a sensitivity or a true positive rate. So it measure the actual positive were correctly predicted. It's crucial for detecting important events such as disease screening. Okay, so where a false negative could have a serious consequence. So let's take an formula. Formula of the recall is true positive upon true positive plus false negative. So it used for the, let's take an example like how many actual positive were correctly predicted. Okay, we want to work on the actual positive only. So it's important for the detecting diseases like cancer screening. Okay, cancer screening, for that we use. So let's see the next topic here. Like take an example, if there are six actual positive instance and the model correctly identify five of them, the recall is 5 upon 6. Okay, so it gives the accuracy of 83%. So there is no code recall for recall. Okay, let's take one example on this also. So wait a minute, guys. So let's see. So any doubt in recall, or once again I have to repeat, guys? Recall. Recoil is also known as an sensitive or a true positive rate. Okay, so it works on the measure how many actual positive were correctly predicted. Okay, so that's the working of the recall. So let's take the example. My voice is audible to all. Hello.
Yes, sir.
Input time we have
Yes,
to
sir.
write. Then after that, let's take example for the recall from sklearn dot matrix import. We write import recall score. So same data we have to take. So like this we have to write, and here we write recall equals to recall score In recall score, we have to write y true, why it is not coming. Y true is not coming, y true, comma, and we have to write y predict. So like this we have to write, and here we write print, and f string we have to give, and here we write the prediction is we write, and here we have to write recall, and after recall we have to write colon dot to f, we have to write up to two decimal values. So let's see what recall value it will give. So the prediction, why it's take a prediction, we write prediction, the recall value is, so like this we have to write. So it will give the recall value as 83%. The actual values are corrected. Okay. So the actual values are 83% corrected. Which are actual values here? Anyone? What are actual values? What are actual values? Anyone? Which one is an actual value? In this data, which one is actual value? Guys, which one is actual value? And which one is predicted value?
Actual values.
Which one is actual value?
Y true.
Yes, y true. And predicted is?
Y predict.
Yes, correct. So let's take a next example is, okay, so next we have to see is in this recall f1 score is there. So the f1 score is a harmonic mean of the precision and recall. It's useful for the matrix when both the positive false and negative false are costly, like there is an we got both false positive and false negative, as it balance the trade off between the two error. So this is the formula, like f1 score equals to multiply of the precision and recall upon precision plus recall. So take an example, like if a model has a precision of 80% and a recall of 83%, the F1 score is the F1 score we got as an 81%. Okay. So this is like normal in between both, like from recall and from precision. So next we have to see the receiver operating characteristic. So ROC curve. Okay, it is also known as ROC curve. So what is an ROC curve? The ROC curve, receiver operating characteristic curve, is a graphical representation of a classification model's performance across different threshold values. It plots true positive rate like TPR is known as recall values, and false positive rate. Okay, a good classifier has a high TPR and low FPR, like false positive rate. A good classifier has a high true positive rate and a low false positive rate, meaning it's correctly identified positive cases while minimizing the false alarm. So true positive rate is known as recall also. So let's see the code for this. So here TPR is high and false pos false positive rate is low. Okay, so that means a good classifier. Okay, so let's see the ROC curve. So here we write import numpy also we have to as np and import matplotlib dot pivot plot pyplot as plt we write, and here from sklearn dot matrix import roc curve roc not this one roc curve and auc. Okay, so like this we want, and from sklearn dot linear model import logistic regression. We want logistic regression also. So here is a true labeled and predicted probabilities. Let's take and the true label is we take as an y true. So this is the true label. So here we have to write np dot array. Np is not taking np dot array we have to write, and in this we give the values of the true labels like 0 comma 0 comma 1 comma 1, and here we write y score. Y score equals to np dot array. Numpy is not working. Okay, so here we write in this we have to write the values. So here we write 0 0 0.1, 0 0.4, and 0.35 we write, and after that 0.8. So here we take four values 0 0.1, 0 0.4, 0.35 and 0.8. Okay, so this value we take as a model probability score. Okay, so let's compute the ROC curve value. So here we write FPR we write and TPR we write, and here we write threshold also we write, and let's write ROC curve of y true and y score. So like this we have to write, and why it gives an error, y underscore score. Okay, so next we have to take is here we write ROC AUC as any variable name we can take. So here we write like this, then AUC we write, then in that FPR. Yeah, my system is not working properly. FER and TPR we have to write. So we compute the so here we compute the FPR and the TPR. Okay, for the AUC score. Okay, so here we write. Then we have to plot this ROC curve. So here we write PLT dot plot. So plot we have to write, and here we write FPR comma TPR comma thresh not labels. Here we write labels equals to. So here also we use ROC is we write ROC curve we write ROC curve of ROC curve of AUC AUC equals to, then we have to use a curly braces, then here we write ROC curve of, not ROC curve, ROC of AUC. Okay, so we write off ROC underscore AUC. We create an variable here, so that we have to take here. Then here we write dot 2f we have to write. So like this we have to write, and one again we have to use plot. So plot of, here we have to write 0 comma 1, and then after that here we have to write is 0 comma 1 once again, and then here we write, here we give one variable as an line style, then after that is equals to, like this we have to write, and when then we have to give the color of this, like color equals to, we write here color equals to red we write, and one more we have to take, and labels equal to, here we write random guessing. So like this we have to write, so it is used for the diagonal line. Okay, so next we have to take is plot dot x label we write, x label we have to write, and x label means here we write the false positive, false positive. You know what is x label, guys? X label, you know? X label means on X lines. On X line, we write something in the vertical. In the vertical, we are writing. Hello, I'm audible, guys. Hello.
Yes, sir.
So on x-axis, we write something sentence. Okay, like age or student. Like this, we write for showing the relationship between the x-axis and y-axis. So this is x label, the positive rate, and y label is, here we write true positive rate. We have to write true positive rate. We have to write, and one more we have to take is plt dot title. Plt dot title, and here we write simple ROC curve. We write ROC curve, and next what we have to do is plt dot legend. We have to write plt dot legend, then plt dot show. So this is the code. Okay, so let's see the output, what output it will give. So it takes a time, why it gives so many error, like in unit.py. Line 2D has not property labels, where we write labels. Okay, it's not a labels, it's a label only. Let's check once again. has no property labels where we write labels. Once again, it gives error. This is also a label, not labels. Once again, it gives an error label.
Maybe spelling mistakes, sir.
Where? Yeah, label spelling, yes. L-A-B-L-E, label. Yes, now it is correct. Yeah, see, it gives the figure of the ROC curve. So this line shows the direct linear regression. This line is straight line. Okay. And the blue line is showing the ROC curve. Okay. This is ROC curve we got. So we use Matplotlib for the plotting the ROC curve. It is work on the ROC. Okay. Like on Matplotlib, there is a one library called Matplotlib. By using that Matplotlib, we able to show the output like this. Okay. So we got like this output. So wait a minute. So AUC means area under the curve. Okay. AUC means area under the curve in this area. Okay. So it's a 75% of data is come under the ROC curve. Okay. And higher AUC is closer to 1. Okay. So it's closer to 1. This higher ROC, and lower is nearby 0.5. So closer to 0.1 means for better classification, and it's closer to 0.5 means poor classification. So it's known as a random guessing. Like actual values we are randomly guessed. Okay. So any doubt up to here? So you can put this one in your project also. Okay. Can I give this one to you guys?
Yes, sir.
Okay, wait a minute. I have to save this. I give you this complete codes and all that things first. Go with that. Okay. And I will take attendance at 12. Okay. Okay, guys. And please uh, do practice of these codes. Okay. Okay,
Okay, sir.
guys.